And welcome to the Agronomists, everybody. I'm your host, Sean Haney. Thanks so much for tuning in tonight. Hope you had yourself a great Monday. We're here for another episode of the Agronomists. I'm really looking forward to tonight's discussion. I've had so much fun talking to entomologists across the prairies focused on beneficial insects. We did season 1 of Pest and Predator podcast. We're launching season 2 tomorrow. And to kind of celebrate that, what I thought I would do is bring in some of the people we've been talking to, some of the researchers that spend their careers focused on some of these beneficials. Thought I'd bring them in tonight and we'd have a kind of a longer form, fun discussion and take some of your questions on beneficial insects. And some of the stories on how some of these beneficial work in the field are very, very sci-fi like. They are pretty exciting and they are very interesting stories that I always enjoy, and I know you will as well. We are live tonight, so of course you can participate in the discussion by entering your comment or question in the box, whether you're watching on Twitter, YouTube, or Facebook, and there's some of you who are already doing that. Greatly appreciate some of you that are providing some of your commentary. There's already questions being asked of our panelists. So let's not waste any more time. Oh, hey, before I forget, remember you can qualify for CCA credits. So go to realagriculture.com and do that and sign up for our agronomist email. We'll kind of prompt you this show is going live. As well, we'll remind you in the morning to sign up for those credits as well. So let's bring in tonight's guests. It's a full bunch, and for the first time ever, instead of having 2 panelists, we're having 3. This is going to be a lot of fun tonight. Want to introduce right off the hop, we've got Dr. Tyler Wist with AFC out of Saskatoon. Hey, Tyler, how are you?
I'm doing well. Thanks, Sean, for having us on here.
Yeah, it's going to be a lot of fun. Also, Dr. Meghan Vankosky with AFC as well. Hey, Megan, how are you?
I'm good. How are you?
Doing fantastic. And
hopefully people can't hear my puppy snoring in the background.
Hey, there could be worse things we could hear in the background. Also, we've got here out of Manitoba, we've got Dr. John Gavloski. He's with Manitoba Agriculture. John, thanks a lot for joining us here tonight.
Thank you. Yeah.
John, Ray wants to see your shirt.
Yeah, we've already got people in the chat wanting to know what is on John's shirt.
Okay, well, there's a front and a back side to it, actually. We've got several beneficial insects right here. Lady beetles, wasps, ants. And if that's not enough, we've got all kinds of cool things on the back as well. I don't know if you can see those. But, yeah, there's just too many beneficial insects. I mean, they're everywhere. So,
that's great. So, John, why don't you start off and kind of hit us from the top. We hear a lot about beneficial insects when we go to agronomy meetings. Why is this such an important topic for farmers to be considering as we get into the growing season?
Yeah, great question. One thing that I can't stress enough to farmers and agronomists when I'm speaking with them is that in order to farm most efficiently and economically, the way you view insects and the way you react to insects is vitally important. And now, Sean, if I was to ask you for a couple beneficial roles of insects, can you throw a couple at me?
The roles that beneficials play?
Yeah, sure. What ways are insects beneficial?
Well, they're working for you for free.
Wow, Sean didn't know.
Yeah, but no, what do they do? What do they actually do? That's what I want to discuss here. What do they actually do that's beneficial?
I don't know what answer you're looking for. I'm sorry.
Well, so people
why would we call them beneficial, right? Like what kind of a term is that?
So what I want to get at here, usually the answers I get are they pollinate, they eat other bugs, but there's a few that get forgotten that no one ever throws in. They eat weed seeds. They can be major weed seed predators. They're decomposers. And the list goes on and on. There's actually, we could spend a whole hour on this, actually. I won't. But anyway, insects are vitally important. They've got many, many services they provide on the farm, not just pollinating and eating other bugs. There's a whole list of them. So the real challenge you've got is when you're trying to control crop feeding insects, do you really want to eliminate all these other valuable services? And they're happening on every farm. So the big challenge for any agronomist or farmer out there is how do we keep the crop feeding damage to sub-economic levels without eliminating all these beneficial roles? And so hopefully we'll be able to cover some of that tonight.
Oh, that's pretty cool. Tyler, you want to add to that?
Yeah. So what I was getting at was, insects are just insects. They're not really beneficial unless you put them in terms of helping humans. And so we got a few comments on the side saying we got pollinators and they're out there. Pollinators will increase your crop yield. And then we've got ones that eat the bad bugs. And that's probably what we're going to focus mostly on here tonight. So someone was trying to spell parasitoids. Hopefully you spelled it a bit better, but good on you for trying. And let's talk predators as well. So a parasitoid is a special kind of predator. So we can talk about them kind of in the same bit. And I love that John brought up the weed seed predators as well, because a lot of our ground beetle species are running around down there eating your weed seeds in the field, getting rid of that weed bank.
Well, never mind parasitoid, trying to spell it. I'm just trying to say it. So it's a win for me. Megan, why does this field of beneficial insects, why does it interest you so much?
Well, I did grow up on a farm. We didn't farm big crops, but we farmed cattle. And to me, it's just a way to kind of return to where I came from in terms of being able to be productive as a scientist, but also contribute back to a farming community. And I've always enjoyed biological control and the idea of being able to use insects to manage pest insects. I actually got called a hippie when I took some agriculture classes at the University of Alberta during my undergrad, because I came from more of a biology background at that point and was all about the nematodes and the parasitoids and the predators and everything else as a way to manage pests. So I really like to get out and show people what's positive and what's neutral in their fields, and that there's a lot of diversity out there that we don't really pay a lot of attention to because we're focused on the flea beetles and the cutworms and all of those things. So
for sure. John, you ever been called a hippie?
Not recently anyway. Not enough hair to be a hippie.
You need hair to be a hippie.
Ever since you cut your dreadlocks off, hey, John?
Okay, what we're going to do is we're going to watch tonight's actually one and only clip. I knew we were going to have a lot to discuss. I've got a ton of photos in the library here that we've collected with our panel tonight, but I'm going to show a clip. It is with Dr. Haley Catton, and she's talking about the power of beneficials. Let's load up the first clip, and then we'll get back to our discussion.
All right.
In any crop field, there are a lot of different kinds of insects. People may be most familiar with the pest insects, and there are pest insects out there, but there's a whole bunch of other insects that are actually doing good jobs that are eating those pest insects. So we call them beneficials because they're doing the work that we want them to do. They're eating the pests. So they can eat the eggs of the pests, they can eat the larvae of the pests, they can eat the adults of the pests. And so they're what I call or what we call free labor, or some people call them an unpaid army. So they're out there just living their lives, doing their thing, which happens to be beneficial to us.
And out of all the beneficials, which one do you find the most economic benefiting?
That is an excellent question because we don't really have dollar values on them yet. I would say probably our biocontrol agents, so those are specialist insects that are released to control specific pests. So in general, you have some insects that'll eat anything, like spiders, for example. We call them generalists, because in general, they'll eat anything. And some are called specialists. So they're specializing on one pest species. And those ones, because they kind of focus on the pest species, I think are probably worth more money.
And what do you think most growers don't realize about beneficials?
That they're doing free work, because we don't pay for them, we don't release them ourselves. They're just out there. I think maybe growers aren't aware of the contribution that they're making. And that's something that I want to quantify actually in my new position. Eventually, it's a big goal, right? But eventually I'd love to put some dollar values on how much money these beneficial insects are saving producers. So usually when people spray, they'll do a little bit of scouting first of all. And you can do some sweep netting. You can also look along the ground. And you're looking for specific well, depending on the crop, right, you're looking for specific insects. So let's take cereal leaf beetle as an example. That's a pest that I have here in this cage. It's new to Alberta since 2005, and the adults will live on the leaves and make holes in the flag leaves, which would reduce yield. So if you wanted to know whether to spray for cereal leaf beetles, you could do some sweep netting, right? And if you do a bunch of sweep netting and you find very, very tiny little black wasps, you may have the beneficial biocontrol insect in your field called T. julis. And this is the one that we think is worth a lot of money, because we don't even see cereal leaf beetle around Lethbridge anymore since so many of these were released. So if you see these in your sweep net, then you may be having a lot of beneficials in your field and you don't want to spray, because when you spray the cereal leaf beetles, you're going to kill all the beneficials too. So the main message is that there's a lot going out in your field. It's a whole ecosystem of insects, and only a few of those species are actually pests. So sometimes you have to spray out the pests, but just know that when you're making those decisions that you're spraying out a whole bunch of insects that were doing free labor for you, and once they're gone, they're hard to get back.
You said you've been looking for help from producers. Can you elaborate more on that?
Yes, I'm looking for field sites. So to do some of this work, to determine economic thresholds, to figure out how much beneficials are worth, we need field sites with cereal leaf beetles in them. And they're actually hard to find right now. So, around Lethbridge anyway. So if you're a producer and you have a field with a cereal leaf beetle problem, or you expect there will be one, it would be great if you could contact me and we could set up so that you could do some research. We could do some research in your field. And the benefit to you is that you get to learn exactly what's in your field. Like, you get professional entomologists, us, to come in and tell you what you've got.
That was Haley Catton, AFC Lethbridge. Okay, let's hit off here. Maybe, John, let's start with you. You submitted a whole bunch of different examples, as well did Megan and Tyler. Which one would you like to start with to talk about?
Hold up.
Oh, hold on. Okay, sorry, Tyler, go ahead.
Well, Haley mentioned the cereal leaf beetle, and we've got a picture of this cereal leaf beetle parasitoid that is, she's kind of a victim of her own success there, because T. julis does such a good job controlling cereal leaf beetle. It's that slide there. So Haley sent me this slide. Hopefully you're able to pop it up there.
I am. Just give me a second to find it.
Cereal leaf beetle and cereal leaf beetle larvae. Super gross while you're looking for that. They carry their own feces around on their back. Ooh, that's a good one. I wonder who took that picture.
Okay, cereal.
There we go.
Oh.
Yeah, you had it.
Right there? No.
Nope. Those are all good, though. Ooh.
I had it.
There we go. And Haley was talking about an unpaid army, and I love that she was dressed like she was in the army. She had her
she did.
On there.
Is this the one you're looking for?
No, but that's a beautiful.
Okay, well, tell me when I get to it.
Okay.
Well, while you're looking for it, I believe that Haley. Oh, you had it.
Oh, right there. Oh, sorry. Yes, that's the one I didn't have labeled.
Go.
Yeah, go ahead.
Yeah, sorry, that one came in.
Haley's still looking for volunteers for this work, so
yeah, Haley is still looking.
Leaf beetles in your field. Let her know.
Exactly. Okay, Tyler, talk about it.
Well, check out that gross little larva there, and you see that streaking on the leaves. So that's what the larva does. It sort of eats and leaves these windows. And so around our Saskatoon fields, I've seen these windows, but we haven't found the larvae before. But check out that wasp. It looks like it's riding that feces-covered larva. And that's T. julis. Right now it's laying an egg inside to that larva. And yeah, pretty soon it's going to be the end of that larva. So that is a parasitoid.
Now, all beneficials are not parasitoids either, right?
No, that's right. So this is a specialized predator where it's actually the offspring of the female that does the killing. So that female, she contributes to the death of that larva, but it's her offspring that wind up doing the dirty work.
Okay. Megan, do you have a comment about this one?
Not really, just like
how
Haley
about back
said
to our regularly scheduled programming?
they're very effective. They've done a really great job to manage cereal leaf beetle. I remember in university, in my early entomology and agriculture classes, seeing pictures of farmers in the States whose pants were just covered with insect feces after walking through cereal fields because they had so many of these beetles. And we've never had an issue like that in Canada. And I think a big part of that is this parasitoid.
Okay, question here from Peter Johnson. Oh, shoot. Hold on here. Question here from Peter Johnson. Says, why do cereal leaf beetles always seem problematic in the same fields? Specific areas, the parasitic wasp doesn't seem to work. What is it? Is that a common thing, John?
They can be kind of localized in their distributions. We've had pockets in Manitoba where they were more abundant, not quite economical. I think the other thing that happens, some agronomists are really good at identifying cereal leaf beetle, and it's an insect that gives a lot of people a lot of problems because the tiny larvae, both Meghan and Tyler mentioned the feces on them. They cover themselves in something called a fecal shield. So they cover themselves in their own feces to make them less palatable. I guess it works. But when they're on the leaf, they almost look like a little drop of oil or debris. And so I think they can be overlooked in a lot of fields. So you do have to look carefully. Sometimes it's hard from a slide to put things in perspective, but it may look just like a little drop of oil. So sometimes people may just miss seeing things that are in the field. I don't know if they're always in the same field though, year after year. They do move around, but again, within a region, you can have localized populations of them.
Good. Okay, Meghan, where do you want to go next?
Well, I was just going to quickly address Peter's second question, or he pointed out that they're having issues with cereal leaf beetle in Ontario right now. And I don't know if anyone has actually tried to release the parasitoid in Ontario. Tyler, John, do you?
Yeah, that sounds like an opportunity. So the background on the parasitoid is they're rearing them at Lethbridge. And if you tell them, hey, I've got a cereal leaf beetle outbreak, they ship you a bunch of parasitoids and you release them right in the field, and then they establish. So perhaps we've got an opportunity here.
I know our provincial colleague in Ontario has been in touch with Haley regarding the parasitoids. And one of the reasons I know that is I was bumped from getting a load of parasitoids last year because, or 2 years ago rather, because there was a greater need. Now, I don't know, I know Haley's been having trouble rearing enough of the parasitoids because they're doing such a good job in Alberta. It was hard for her to build a strong colony, but I know Ontario was trying to get T. Julis from Haley to get them released there.
Cool. And yeah, this is fun. This is good. This is a really great question, Meghan. Thank you. Or great catching Pete's question. I appreciate that. And so Pete and now somebody else, Farmer Schneck says, does the cereal leaf beetle overwinter in the climate? I assume that.
Oh yeah.
Go ahead, John.
Yeah, if they mean in the Canadian prairies, yes, they overwinter as adults quite well. They'll often move out of the field to where there's some debris, crawl underneath it, and come out in the spring. Short answer is yes, they can overwinter in prairie climate quite well.
Yeah, and if they can
overwinter under a nice blanket of snow.
Nice blanket of snow, exactly, Tyler. Okay, Meghan, you want to lead us in the next direction? You pick. This is like This is like bug wheel of fortune.
It's so much pressure.
We want to stick with parasitism? We could throw up a few more parasitoids.
Sure, that sounds great to
me. I love
and then we can move on to predators later, maybe.
Okay.
So Tyler, John, what other good parasitoid pictures did you send to Sean?
Oh, I sent a flea beetle parasitoid picture because John hates that one because it gives false hope to producers.
Right, so it's the next slide. There.
There we go. There's my Croctonus. So she's going after that crucifer flea beetle there. And but Julie Soroka's work showed that really they didn't do much more than 2.5% parasitism. So they were not enough to control populations of the flea beetles. So maybe more work could be done there. Maybe there's a way to boost their populations, but at this point in time, right, false hope. So I just wanted to throw that one up there for John's sake.
So how do we measure whether or not they're effective? Does there do you measure what population you need of the parasitoid to control the host? Like how do you figure those kind of things out, John?
You can collect your target pest and actually dissect them to see what percent are parasitized. And just to give an example, we've been releasing the T. julis in Manitoba, and I've been sending Haley larvae of cereal leaf beetle the last several years, and they actually dissect the larva and will tell me what percent from a sample had the parasitoid. And that's a success story. A lot of the samples come back 50, 60%, very high levels. Now, you could do the same thing with flea beetles. Tyler alluded to 2.5%, so I'm assuming someone did take the time to do some dissections at some point. But that's what it takes, is collecting a sample, dissecting, and seeing if the parasitoid is there, or rearing the parasitoid from the host.
So like Peter points out here, is it only 2% parasitism, if I said that right? Because numbers are too low, need more of them? Like is that the issue, Tyler?
Well, it might be the issue. So I actually took this individual back to the lab and I made a few videos, and she was very unsuccessful in parasitizing that crucifer flea beetle. Because if you know anything about flea beetles, they've got big thighs for jumping, and you get close to them and they jump away. So maybe Microctonus just has a lot of trouble actually catching them to parasitize them.
Okay.
Maybe.
Let's I want to talk about this the wheathead armyworm. Do you want to go to that one?
That sounds great.
Because that one is a crazy story. This is where stuff gets real.
Yeah.
So talk about this.
All right. I'm actually going to be presenting this tomorrow to a Sask wheat audience. So I think you can still register if you like. But yeah, I've got a lot of slides and even a video on this wheathead armyworm. So this maybe is not a pest that you're very familiar with, but it has about 2 generations, and it can do quite a bit of damage, but it's really spotty and kind of hard to find. And probably the reason why it's so spotty and we don't get big outbreaks of it is because this Cotesia parasitoid has started to attack it. And so what we're looking at here, you can see the caterpillar there. So that's the wheathead armyworm. And it has about 20 or 30 Cotesia larvae bursting out through its body wall right now. So you can see them up there at the top, still hanging on. And you see the kind of whitey stuff? So as soon as they burst out, they start to pupate right away. And so this was early August. So these are what we're going to see up on the heads. And I've been getting a lot of pictures sent in of these white cocoons, and people say, hey, these look like these eggs. What are these eggs? And really what it is the pupae of these Cotesia. And they have burst out of the caterpillar, and yeah, but they don't kill the caterpillar right away. And so often the wheathead armyworm wanders off, and all you see are these Cotesia clusters. They're often up on the awns. So if you've got a wheat or a barley field with awns, they're often up there, which is kind of strange for a caterpillar to be hanging out on the awn. So I'm wondering if it isn't messing with their brains right before they emerge.
The carnage, though, just look at that.
Yeah, it's dramatic. This is the one, Tyler, you talked about how this is like an episode of Alien.
That's right. Yeah. So Ripley Scott, I'm sure he ripped off nature multiple times. So those xenomorph aliens are basically parasitoids of humans. They're more of a solitary endoparasitoid, though. What we're looking at here is a gregarious endoparasitoid because there's so many of them coming out of one individual. So what's actually really cool about these Cotesia is they're all going to be female wasps when they come out of their pupal casing, and all clones. So all of these individuals came from one sting event. They came from one egg that just multiplied inside the body of the host. And so they are all genetically identical. So Parasitoids can do some really cool things genetically.
So, question here from Pete, talking about armyworms out east. Does this same parasitoid work on all armyworms, John?
It works on the, it's got quite a broad host range, and it does work on the one that we call armyworm, or some people call it serial armyworm or true armyworm. It definitely attacks that one. We had actually a very significant armyworm problem in Manitoba last year, and most of the feeding to the crop was happening in late June through mid-July. In late July, I started to get a lot of people sending photos of, quote, what are these egg masses at the top of the plants, which, as Tyler alluded to, were the pupal clusters of the Cotesia. They were very abundant and obviously very numerous in the armyworms that we had last year. And we really didn't have much of a second generation of the armyworms last year. So it was actually quite evident that the Cotesia had done quite a good job keeping levels down, at least for that second generation.
Yeah, you mentioned Manitoba. Jason points out we deal with serial or true armyworm every year in the south central part of Manitoba, mostly in barley. So Jason agreeing with you there. What's that, Tyler?
Drop down there too, and we've got the Cotesia cluster up on the awns. So check that picture out.
Right there.
Right there, yeah. There we go. So that armyworm's crawled away, and all we have are a bunch of Cotesia. And so the question about, so Cotesia is a genus. There are many different species, and some of them can attack a host of species. So Vincent Hervé, he's a recently hired AAFC scientist, but he did his PhD on Cotesia vanessae. And what he basically did was he just got a bunch of different caterpillars and tried to see if Cotesia vanessae could attack them. What was super cool is he would have this whole life cycle down to an absolute science. He'd start a stopwatch and he would know exactly when those Cotesia were going to burst out of the body wall of the armyworm. And so we used that in Canolab quite a few years back now. And he would have it written down on a piece of paper. Okay, at 5 o'clock, these guys are the ones you want to be looking for. And yeah, it was super cool.
I got a question here from somebody's text. I'm just going to bring us all back here for a second. Meghan, I'm going to ask you the question. Can you clarify pupae versus larvae?
Absolutely. So those are different life stages. So most insects that go through a complete metamorphosis have 4 life stages. They have an egg stage, a larval stage, which is mostly what we think of as caterpillars, and then a pupal stage, which is a quiescent stage, really, when the process of metamorphosis takes place. So inside the pupa, the larvae finishes development into the adult form, like a butterfly or a moth or a beetle. And so a number of insect orders have this complete metamorphosis and a division of labor. So the larvae and the adults tend to eat different things. But then other species have incomplete metamorphosis, like grasshoppers, where we have a nymph stage instead of a larval stage. And so in a grasshopper life cycle, we have eggs, nymphs, and adults, and no pupal stage. And the little grasshoppers look just like the adult grasshoppers, except they don't have wings and they're not sexually mature. So that would be the biggest difference between the larvae and the pupae when we're talking about life stages.
Okay, cool. Another question I had here, John, how do you figure out whether or not there's an insect that's going to be a predator or a parasitoid on another insect? Like, how do you figure that out? Does that happen in the wild? Does it happen in the lab? How exactly does this work?
Yeah, it can happen in many different ways. It could be through observations in the field, in the wild. It could be through lab experiments where you take the potential predator or parasitoid insect, give it some host and see what it's feeding on. So there's various ways. And both really is the answer. It could be done in the field or in the lab.
Megan and I were talking about this when we recorded our next episode of the Pest and Predator podcast together. It was where I said, like, if you were trying to figure out what preys on a duck, the duck is quite large. You can see it. If you put your eyes down to grab your lunch, you don't lose it. Like when we're talking about some of these insects, they're 2 millimeters big. Like to do this in the wild it just seems unbelievable, Megan.
It is, but people get really creative, and there's different ways to do it in the field. A colleague of mine in California used cameras that were set up with infrared, so she could put a sentinel plant out in the field and then put the camera on it and watch and basically record 24 hours of footage to see what was coming into that plant to eat the pest that was on it. So we can be really creative. And of course, work that we can do in the field is always going to give us a better idea of what's actually going to happen in a farmer's field. But we often start in the lab with really simple conditions where there's not a lot going on, so that we know for sure if that insect if the Crabby Beetle, for example, is eating the pea leaf weevil or not. And once we know that basic parameter, then we can start getting more creative and get more complex and set up different systems to see what's going on. So similar to the question about how do we know what parasitism rates are, doing it in the field is generally the best, but we can start in the lab in really simple situations as well to just answer some of those basic questions.
Ray points it out, passion equals creativity. Sorry, go ahead, Tyler.
Well, there's a couple of other ways too. I mean, anything that eats poops, right? And so insects often have really hard head capsules. And so if you rip open the stomach of a ground beetle, you might be able to find those head capsules and say, hey, that ground beetle was eating that guy. And we also have molecular tests now too. If you can get a specific primer for, say, a flea beetle, you can say, oh, that ground beetle was eating flea beetles. So yeah, there's some sophisticated methods and maybe some methods that you might just want to push onto a summer student.
It's called paying your dues in the insect world. That's what it is right there.
Right.
Yeah, we all started somewhere.
Exactly. Remember my first job? Oh, I was in the lab and all I did was like go through beetle stomachs. Okay, John, let's give you a pick here. Which one do you want to talk about next?
Well, grasshoppers could be an issue next year if we get another dry summer. So why don't we touch on some of the things that eat grasshoppers?
Okay, which one you want to choose?
So let's start with our blister beetles.
Okay, perfect.
Yeah, you can throw up my echinacea picture too with that one, because that one's also a grasshopper predator. So there's
okay. So
there's the black blister beetle, eh?
Yeah.
That's the black one. Yeah. So now, just to put it in perspective, there's lots of different types of blister beetles. There's 46 different species in Canada, but there's a few of them that the larval stage feeds specifically on just grasshopper eggs, nothing else. And this is one of them. We saw quite a few of these last year. This is the black blister beetle. And there's another one that looks very similar, but it's more of a gray color. And we often see more of these. We often see more of these in years right after the grasshoppers have started to build. And that's because they've got lots of food. They build their populations. They're feeding on grasshopper eggs. And over time, it can help wear that population down a bit.
Okay.
Yeah, do you see that picture of the blister beetle, a kind of golden one on the echinacea flower? So I took that one after the huge grasshopper outbreak of 2002. And I actually found that it was a pretty good, that one there. It was actually a really good pollinator of echinacea because it would stay on the plant like a good hour. So that's the golden blister beetle. And if you check its body shape compared to that black blister beetle, they're in the same genus. So they're in the genus Epicotta. And so not all blister beetles are good in their larval stage, but the genus Epicotta is.
What?
And
how
we
many
also have a lot of bee flies as well.
Bee flies?
Bee flies, yeah. So they're just like they sound. They're a fly that looks like a bee, and they also eat grasshopper eggs. And so they were really abundant as well. But I actually pulled this picture off of a CD, so that's how old it is right now. And so
at least it's not an
Yeah.
8-track. Okay.
You're dating yourself, Tyler.
Yeah.
Hey, that is okay.
What are we looking at
Oh,
here?
there's a good dead
Tyler, do you want to
grasshopper.
cover this? What are we looking at here?
Yeah, so this is a grasshopper, and it's been infected with a fungus called E. grilli. And what the fungus does is it causes that grasshopper to think it's overheating, and it crawls up onto the top of whatever is highest. So right now it's on top of a canola plant, and it just sits there and it dies. And then it starts releasing these fungal spores all over the place as it sits up there kind of swaying in the wind. And so we've been seeing a lot of dead flies as well. And so there's another Entomophora that actually attacks flies. So it's a different species. We had a few pictures coming in on Twitter of these dead flies. Did I do that justice there, John? That was your picture of the dead grasshopper.
Yeah, no, that's cool.
Okay, so John, do you want to? What are we looking at here?
So those are grasshopper eggs. And when grasshoppers lay their eggs, they usually lay them in a big group. And each egg looks like essentially a grain of brown rice, but they're all packed together in a big cluster. So this makes it actually advantageous for some of the very targeted egg predators, because you've got this nice package of food just sitting there. So things like the bee fly larvae, the blister beetles, some ground beetles, even field crickets, they're really good at finding these parcels of eggs and digging them up and feeding on them. So there's the ground beetle that you pulled up. Now, ground beetles, they're a hugely diverse group. There's 983 species in Canada. So there's more species of ground beetles than there are birds in Canada. Hugely diverse group. Almost all of them are beneficial. Many are good predators. And some of them will actually burrow into the ground and feed on things like grasshopper eggs. So they're a group you really don't want to underestimate. They can feed on a lot of different things: cutworms, grasshopper eggs. Some of them feed on weed seeds. Some of them are valuable weed seed predators as well. So they're a group that for a farmer you don't want to underestimate. And one of the things, just as a side note here, that I'll just toss in, I sometimes get the question from canola growers, what harm does it do if I spray for flea beetles when it's not really needed? Am I really doing any harm? At the time of year when the canola plants are still seedlings, there's a really, really tiny species of ground beetle called Bembidium that's crawling around. Sometimes they're super abundant, and they like feeding on insect eggs and some of the small insects in the soil. So always good to check and see if you've got some of those things in the soil before you do any control measures.
Megan, go ahead.
I have a question for John. So with all of these predators of grasshopper eggs, are they eating the eggs in the fall or in the spring, or both? Because most of our pest grasshoppers lay their eggs in the fall and then those hatch in the spring. And so when should we be watching for them and protecting them so that they're eating the most eggs they possibly can?
Yeah, and the short answer is both, because you have some field crickets. There was a study in Alberta where they found a grasshopper egg bed, and they collected some of the field crickets from that egg bed, and they dissected, like Tyler mentioned, they dissected the stomachs of 22 of these. 5 of them weren't feeding, so they probably had molted. 11 of the remaining 17 had grasshopper eggs in their stomach. So field crickets can be a valuable predator of grasshopper eggs, and of course they're feeding in the fall. Now springtime, you're going to have both your fall and your spring. Ground beetles would be one of the probably more beneficial springtime predators of the egg pods. So yeah, right throughout the season, really.
That's good
Hey,
stuff.
before we go on too far, Jason Vogt had a really good, I'm probably saying that wrong, he had a really good comment in the side about the soybean aphid advisor app.
Oh yeah,
John,
I
maybe
saw
you can take that one, right? Because you have more soybeans in Manitoba. But I kind of took the equations that they use, the dynamic action threshold equations that Rebecca's group out at Guelph used when they made that. And I adapted it to the cereal aphid system. And so we put out an app called the Cereal Aphid Manager, and it's freely available for you. And quick download. And you can use it to scout aphids, but it takes into account the beneficial insects in your field, like the Soybean Aphid Advisor app does.
Now, John, if I remember right about the Soybean Aphid Advisor app, they give you visuals because there's so many aphids on one leaf. You couldn't actually really count them. So doesn't it give you a visual to show you what the thresholds are?
Yeah, it gives you some guidance, because with soybean aphids, the threshold is 250 per plant, and the population is still increasing, because it actually takes a lot more than 250 to cause economic damage. You can't count them. You can't sit there and go 1, 2, 3. No. So
that's a summer student job.
Yeah, summer student or not, it would take all day. So you have to get good at estimating levels. That's the trick with soybean aphid scouting. You have to get comfortable looking at a leaf and saying, that's roughly 50, that's roughly 75, 100. And so there's visual guides to help you with that. And so that's the first major challenge for anyone who's scouting soybean aphids, is getting good at estimating levels. Challenge number 2 is getting good at identifying the key natural enemies that eat them, because they can sometimes be abundant and they sometimes look like different things. For instance, lady beetles, these guys, their young stage looks like a little gray alligator on the leaf. A lot of people don't recognize that. Hoverflies, their larvae look like little slugs, but they eat aphids. And then you've got another one, lacewings. Their larvae look like brown alligators. So that's challenge number 2. Get to know those. And there's something called dynamic action.
Massive mandibles.
Massive mandibles on the lacewings, for sure. Get to know the things that are preying on the aphids, and you can actually factor them in to the threshold, and that the threshold gets adjusted. So if you've got a lot of natural enemies, you could be well over 250, and the right decision is don't spray, because over time the levels aren't going to be increasing, they're going to come down.
Farmer Schneck watching on YouTube mentions about killing grasshoppers, windshields.
I saw that as it popped up and had a good chuckle.
Yeah. Megan, I'll ask you this one, good one from Peter Johnson. What % of insects are beneficial versus pests?
I saw this question in the chat too. It's a great one. So the way I think about it is every pest has a predator, and every predator of the pest has its own predators and its own predators or parasitoids and so on. So I think a really small fraction of the insects that we see on a daily basis are pests, and the vast majority of them are beneficials or neutrals in terms of a farming situation. And like Tyler was saying at the beginning, it all depends on a human perspective, right? So all insects are just insects doing their thing, but they're pests because they're eating our crops, or they're in our houses, or we're afraid of spiders like I am. And so the percentage of insects that are pests, I think, is quite low compared to all of the beneficial species. And just remember, there's always something that eats something. So
circle of life.
Absolutely. It's all a big pyramid, right? The pests are just a little piece at the top.
I think on Jurassic Park they talked about that. Everything gets eaten by something.
Yeah. So parasitoids have hyperparasitoids that parasitize them. It gets very complicated and very messy sometimes.
We're going to get
That's the bane of my existence.
Sorry, what's that, Tyler?
Those hyperparasitoids. Hyperparasitoids, they were the bane of my existence when I was trying to come up with the cereal aphid manager, because we had one specific primary parasitoid that was attacking the cereal aphids, and I kept trying to rear them out of the aphid mummies. And if you want to know what an aphid mummy is, you can throw up that picture of the prey-on mummy I've got there, Sean. And so I would be rearing these things out, and I'd get like 60% hyperparasitism. I didn't have enough primary parasitoids to do the work that I wanted. But then I was like, you know what? I have to take into account these hyperparasitoids if we're going to be using Yeah, there it is. That's a mummy there. So this is a dead aphid, and the aphid used to have inside of its body a parasitic wasp larva. In the case of this prayon, the actually exits the belly of the aphid and makes that pupae underneath it there. And so you don't always see that. So the aphidius, the one I was working on for the serial aphid manager, it doesn't, well, it splits the belly of the aphid, but it doesn't crawl out. It stays inside, and it glues itself onto the leaf or the wheat head so that it can stay up in the top of the crop. And it actually cuts its way out of the back end. And so in the parasitoid, of getting a primary parasitoid crawling out the back of the aphid, I would get these little tiny hyperparasitoids that would come out, and they were just no good for my research.
This is some of the cool stuff that is going on inside the canopy that just absolutely blows me away. We got mummies, we got cotesia, we got stuff happening that really provides some really awesome biological stories on what is happening inside our crop. Question here. Hold on here 1 second. Yeah, Lara says disgusting but so cool. She's right. Absolutely. And
Yeah.
Megan, I'm not going to let this one pass. You're an entomologist, but you're scared of spiders. What is that? Explain that to me.
Many legs.
Well, I'm arachnophobic. It's just it's a fear. I don't know why, but I've always been. I'm better now. I'm not quite so bad about spiders as I was as a kid, but yeah, I've just never been a fan. And in the entomology world, it's like a 50-50 split. Entomologists either really love spiders or really hate spiders. And of course, spiders aren't insects, so they don't really matter. But something with over 8 legs, I can handle no problem. Centipedes, millipedes, anything like that, cool. But exactly 8 legs is not cool at all.
It's like a rule written somewhere. It's like an introductory biology. Okay, Megan, you want to pick a predator you want to talk about?
Well, I think we've already kind of gotten there, but maybe let's talk about crabby beetles a little bit more, just because I think they're so important. They eat everything from slugs to insect eggs, like John was saying, to weeds and weed seeds. And so there's a lot that they're doing and contributing to and going on. We have some issues right now with an inventive species, Pterosticus millenarius. It's a really effective predator of a number of things, but it's kind of changing the ecological niches and shutting out some of the other species so that we're finding that they're not so common anymore. But yeah, crabby beetles are really pretty cool, and we find them in all of our major crops. They're quite mobile, they'll move around, and so they're definitely worthy of being aware of and protecting.
Awesome.
I think John
Hey,
had
so the caterpillar hunter there, Sean.
The caterpillar hunter?
Yeah,
fiery
it's that
caterpillar
Calisoma
hunter,
ground
yeah.
beetle. It's got a Eartha armyworm in its jaws. I didn't take that picture though. I think it might have come from Hector.
Oh, from Dr. Hector Caracamo. Beetle. Ooh, there it is right there. Hold on.
Yeah, there it is. Beetle
Look-
eating
What?
Bertha. Yep.
What's that, John?
One thing you don't want to underestimate is how many caterpillars a ground beetle can eat in an evening. There was a study at University of Iowa. They were feeding ground beetles different sizes of cutworms, and they tested a few different species. And for the larger caterpillars this size, most of their species were eating anywhere from about 2 to 5 caterpillars per evening. For the tinier caterpillars, they were eating about 8 or 9 in an evening.
Big
So when
appetite.
you look at the
amazing.
numbers,
Yeah. Megan, what's that?
I said big appetites for small beetles.
Yeah, no kidding. This is like,
Pterosticus and Calisoma are big in terms of what a beetle looks like, though.
yeah.
Compared to
They
us,
are
they're
big.
small. I think John could eat a whole lot more cutworms in one sitting, though.
John, you're a big fan of cutworms?
Well, I like doing cruel things with cutworms. We did do an experiment on my porch one time where I was entertaining nephews and we were tossing cutworms into a ground beetle container. And I ate 8 or 9 of them before I got tired
Guilty.
of doing it. It thoroughly entertained my company. And
This is like hashtag fun with entomologists. What do you do in your spare time? It's like having a snake, pet snake, and you're dropping mice into the cage. That's pretty good
That's
stuff.
exactly
next
right.
time you have your in-laws over, you'll be hit.
Yeah. My mother-in-law is terrified of birds. I'm not sure she's going to be into beetles and cutworms. We got a question here from Gord. He says, some people say if a crop is attacked, for example, by aphids, it is unhealthy, example, high in nitrates, incomplete proteins, etc. Is there any truth to that?
It's a mixed bag.
Okay, Megan, it's a mixed bag.
Yeah. And yeah, I did some research on this in the past. And so there's this idea that if a plant is stressed, it can't protect itself. Or if a plant is healthy, then insects are drawn to it more because the quality of the food might be better. I think in my experience, it's species specific. Some insects take advantage. And so if the plant can't protect itself or its neighboring plants because it's unhealthy, then insects might do very well. Or like if a plant is drought stressed, for example. But other species will tend to prefer plants that are over fertilized or that are growing very well because the nutrients are just better. So
okay, awesome.
I think it works both ways.
Tyler, John, you guys agree with that?
Yeah, it can work. Yep. Definitely work both ways. Soybean aphid. We know that plants that are potassium deficient will have more soybean aphids on them. That's been well researched.
Okay. Hey, Tyler, I'm going to throw this one to you. What about the new, do you know anything about the new parasitic nematodes that attack corn rootworm that Elson Shields has developed?
So I actually bought a bunch of parasitic nematodes yesterday.
Off Amazon, or is there like Egg Canada sort of bug exchange? You guys are. Oh, it's okay. Okay, go ahead.
Yeah, and so. Well, the parasitic nematodes, they often needs to be kind of wet for it to work. Our dry conditions are not very conducive, like dryland farming is not very conducive to using nematodes. I mean, I paid $24 for a little bottle that I'm going to treat my house plants with. So I don't know much about them attacking corn rootworm, but I do know that these ones that I bought they're specific for things like fungus gnats. So I'm going to water them into the soil to try to take care of the fungus gnats that have infested my house plants since I brought plants home from work. And the greenhouse is infested by fungus gnats and moth flies. And now my house is too. And my wife said, "Cardiologist."
New definition.
Moth flies are so cool.
Yeah, new definition to bring in your work home. John, do you know anything about the parasitic nematodes?
Well, they do work well under some conditions. I know the research done in the eastern U.S., they've had good results. But as Tyler mentioned, a different environment out here, so I'm not as confident that they're going to work here, but it really hasn't been tested. And the other thing, too, when you talk about parasitic nematodes, do note that there are different species of them. There's lots of different types of them. Some of them can be more generalist. Some are more targeted. So you can buy beneficial nematodes online and even in department stores, but just make sure you're getting the one that's going to control the bug you want to.
Ray, he was talking about nematodes, not CBD. He was talking about nematodes. Jason's asked us
$24 a bottle. Isn't that cheap for CBD?
It might be cheap for CBD. Okay, John, question from Jason Vogt here. Have you been able to assess any fields whether the cold temps we had for a 10-day period in February and March that dropped soil temp at 5 centimeters to negative 15C destroyed any grasshopper eggs?
I've been telling people don't count on it. And there likely are some areas in some fields that did get to that critical -15, which is roughly where you need to get it for a few days to kill the grasshopper eggs. The problem with grasshoppers, though, they tend to move to the ditches, the field edges, places like that late in the season to lay their eggs, where there's often a lot of lush vegetation. And those areas are good at trapping snow. So you may get some egg kill if there's eggs right in the field where it gets to -15. But my guess is that in the ditches and the areas that will have a lot of grasshopper eggs, we very rarely see the temperatures get to that -15. So I usually recommend to people, don't bank on there being a lot of grasshopper egg kill, even if you did have little snow and a cold winter. As long as you've got enough in the ditches to have a few centimeters over the ground, that'll be enough to protect them.
Awesome stuff. Okay, so here's the question that I'm surprised somebody in the audience hasn't asked, and maybe they did and I just missed it. But okay, so if these beneficials are so beneficial, how do I build the population of them, Tyler? What are some of the things I can do to really enhance the fact that I'm going to have these insects working for me for free? What do I do?
Well, of course, there's always not spraying them, but you want to work on your economic thresholds. And so if you're nowhere near an economic threshold, you haven't gone close to an economic threshold, stay off the sprayer. If you want to try to, say, bring in parasitic wasps, they like flowering plants. If you've got little corners of your field that just never really produce, your yield is 12 bushels an acre or something, and it's just terrible, maybe think about putting that into flowering crops, just leaving natural areas for these insects to feed in and to reproduce in as well. So if you want to know more about beneficial insects too, like I got my Field Heroes t-shirt on here. You check that out there.
Nice.
That's yeah, we got the Field Heroes logo there, so you can check them out on Twitter and you can see it online. And so someone in the comments had mentioned the knowledge gap between what is a beneficial insect, what is a pest insect. And so that's what the Field Heroes program is trying to bridge that gap by teaching what beneficial insects are. I think that's a lot of what your podcast coming up are all about.
Well, and that's what I want to make sure I mention. Big thanks to WGRF for partnering to make that Field Heroes and the Pest and Predator podcast happen. Really, really do appreciate it. Megan, any more tips from you in terms of how to build population?
Those are for me, those are the top two that come to mind. Conserving some natural areas around your farm or around the fields. And of course, economic thresholds, as Ray says in the chat, judicious use, being careful with what you're using and being aware. Gosh, yeah, those would be the big ones. And I guess not panic, right? Don't think that just because your net's full of insects that you have a problem in the field and you need to spray, because they're probably not all pests. We did a Field Heroes video a few years ago out at Canola Palooza about what's in your net and what to stress about and what not to. Go looking for the pests. Don't go looking for just insects, I guess. That's my best suggestions. John, anything that we missed?
Yeah, I got a couple more I'll add to it.
Awesome.
We used our example earlier of scouting soybean aphids, and if you find you're above the threshold, but you got all these natural enemies, what do? We've got selective insecticides for soybean aphid. We've got insecticides that kill nothing but aphids. So, and the good thing is, some of the newer ones don't even cost that much more than your traditional ones. So use the selective product. That'll preserve your natural enemies. And one more thing that you could try, sometimes you don't have to spray the whole field. And I'll give you an example. They did some research in Wyoming where they treated a rangeland for grasshoppers in strips. So they sprayed 100 meters, and then left the next 100 and did it in strips. They got nearly as good control doing half the field as they did when they sprayed the whole field. And that's because grasshoppers will move around. And if you use a product with a bit of residual, your control really isn't down that much, but you've used half the product and you've left a refuge for those natural enemies. So that can work. Cutworms are often in patches. sometimes you don't need to be spraying a whole field.
Well, here,
Yeah, grasshoppers is a good one because they come in from the roadside. And so if you can catch them feeding on the first couple meters of your roadside, you just blast them there.
And ideally with a selective product.
Yes.
Exactly, John, exactly.
well,
So Jason mentions spreading horseradish around the headlands for flea
Yeah.
beetles. So I think he's getting into a trap cropping situation. I've actually seen a horseradish bush completely skeletonized by flea beetles. There were probably thousands on that horseradish. So they love horseradish. So if you can draw them into a different place and concentrate them before your, say, main canola crop is ready to be damaged, then you can hit them in that crop that you've trapped them in.
so that's like a legit thing.
That's a legit
can
thing,
be,
yeah.
yep.
I mean, yeah.
Here,
Yeah, I don't know that it's been well researched, but there's a chemical called isothiocyanate, and it's what when you smell horseradish and you get that burn, that's the isothiocyanate doing that, and
That's been researched.
that draws flea beetles in big time. And we used to use that in traps when we were trying to collect flea beetles.
Is in their aggregation pheromone.
Aggregation pheromone is something separate. It's a whole different thing. We used to put the isothiocyanate in our traps. We collect hundreds in a day for research purposes. And it just takes a little vial of it. They'll just concentrate in there. No one's ever really researched at field scale, though, to see, can you knock a population out? You would need a lot of traps scattered all over the place. So
Peter brings up, Tyler had mentioned, coming in from the edge of the field. He said the same thing about spider mites. And Farmer Schneck says, hopefully I never have to spray for spider mites ever again. My sprayer still stinks half a year later. Yeah, and Jason says, yep, on the horseradish. And here Ray, I'm not even going to try to say that word, is also in garlic and onions. There you go. Cool. Okay, well, hey, John, I know you wanted to hit on resources. What are some other resources that where people can get more information?
So Tyler mentioned the biggie, our Field Heroes program. A lot of the provincial websites have fact sheets on beneficial insects as well. In Manitoba, we've got a series on beneficial insects. There's a beneficial insects poster, and there's also one on how to maximize your returns and efficiency using beneficial insects on your farm. So you could check our website. We've got an insect page, and we've got some resources there as well.
Well, I'm also going to point out there's this really handy website, realagriculture.com, John, where there is a ton of resources. It's a fabulous site. I don't know who the heck came up with that idea, but it's fantastic.
And if I can sneak one in, there's the Prairie Pest Monitoring Network website as well. We don't have all of our beneficial insect information up there, but a lot of the pest information is there, as well as how to scout for a lot of the major prairie pests that we deal with on a regular basis. So,
absolutely, Tyler, throw that up again. What do you have there?
There we go. That's our handy dandy Agriculture Canada guide to pest and beneficial insects in your field. So
that's the old version.
You can actually find that on. Well, yeah, I've got the original version. It's got a Lygus on it instead of your tea leaf weevil.
There's the new version.
There's the updated version.
They're both good. It's awesome.
Yeah.
That's funny.
So you can actually download that from Prairie Pest Monitoring as well.
Oh, great. That's perfect. Well, you know what? The more resources, the better. Honestly, and yes, Pete is very worried. I am going to get Megan, Tyler, and John's addresses, Pete. I'm going to send them each a Real Agriculture hat, and I'm going to make sure I actually do it faster, Pete, than I sent it to you. I'm going to send it faster to them than I sent it to you. How about that? Would that make you happy? Ray says he has that book, and it is great, even though he is a soils dude. Ray also pointed out this was an awesome episode. I do very, very much agree with him. Fantastic stuff. A lot of great information. We didn't play as many clips tonight, but we had lots of photos to discuss and talk about. So I think it was really, really awesome. We got another question here before we wrap up from Jason. Wheat midge.
Oh, there's no wheat midge in Manitoba, right, John?
Well,
not according to our map.
Yeah, no, we do have.
Let me qualify that.
We've been monitoring using sticky traps periodically. We do have a parasitoid called Macrogleans penetrans that is highly effective against wheat midge, and it seems to be doing a pretty good job keeping our levels contained. So we did have, I'll say, minor downgrading last year, but it was quite minor. Macrogleans seems to be doing a good job. It's a very, very tiny black parasitoid, and we really encourage wheat growers, spray for wheat midge, certainly if you're above the economic threshold. Don't be spraying just in case, because if you're taking out the macrogleans, that's what could get our population building back again. Macrogleans is an awesome parasitoid, and also another reason why not to spray your canola if you don't need to. Macrogleans is going to emerge wherever last year's wheat was. So if you've rotated into canola this year, you could have a lot of macrogleans coming out of that soil looking for this year's wheat field to parasitize the midge. So another good reason to use economic thresholds.
Yeah.
And nectaring in the canola, right?
Sorry.
That little parasitic wasp could be feeding on the nectar.
Yeah.
And don't forget about midge tolerant wheat. Like the SM1 gene was bred into spring wheat at the AAFC Winnipeg facility and tested right there in Manitoba. So I was being a little facetious when I said there was no wheat midge in Manitoba.
We got you.
Of course, we know that.
Well, hey,
Just
for a while,
that, Manitoba doesn't have that monitoring program for it.
For Tyler, for a while, Alberta never had fusarium, so every province has their thing.
Very true.
Okay.
Lara's right. The wheat midge prediction map does look a little scary, and so that is based on the number of viable wheat midge cocoons in Saskatchewan. It's based on 421 fields, and so it's a lot of work. You have to take soil cores from those 421 fields and then wash all the dirt off, and then dissect all of the wheat midge larvae that you find in there, and then there's some math that goes into it, and it gives you an idea of what's going on. And so all that data comes through Ag Canada. David Giffen makes those beautiful maps for us, those heat maps of the wheat midge pressure.
Well, on that note, and the fact that Megan's dog is no longer sleeping, we went for an hour and 15 minutes. This has been so much fun. Great information tonight. I really appreciate our panelists tonight, Dr. Tyler Wist, Dr. Meghan Vankosky, and Dr. John Gavloski. I really do appreciate all three of you being here tonight, sharing some stories, some research, and some insight into beneficial insects. I really do appreciate it.
Thanks so much for having us.
You're welcome, Sean.
Yeah, thank you.
It's
Yeah,
been fun.
thanks for having us.
Want to remind everybody that you can go to realagriculture.com. Make sure you get your CCA credits. A great program tonight. Awesome, awesome stuff. We're going to get a shot of the dog. Oh, look, he's up. He's like, now I'm ready for like a walk or go like play. Awesome. That is so fun. Want to remind everybody, like I said, go to realagriculture.com for the CCA credits. Really appreciate it. We're on every Monday night, 8 o'clock Eastern, 6 o'clock Mountain. Continue to do this through the growing season. This is Real Ag in prime time. And once again, I really appreciate everybody joining us here tonight. Thank you so much for getting real and getting connected with the agronomists. And we'll see you again next week.